Welcome to this video on photovoltaic solar based electric vehicle design. In this video, we will be going to explore the principles behind designing an electric vehicle powered by solar energy. We will also discuss the various components involved in the design and how they work together to make the vehicle move. So, let's get started. Imagine being able to charge your electric vehicle for free just by driving it into the sunlight. That's the power of photovoltaic solar based electric vehicle design. And in this video, we'll be going to dive deep into this and how this technology works. We'll start by exploring the basics of system, including solar panel, buck boost converter, charge controller, battery, inverter, electric motor, brushless DC motor, and regenerative braking. Each of these components playing a crucial role in the functions of the vehicle. In general, an electric vehicle uses a battery that is charged from an external power supply. But solar PV modules are used to charge a battery by means of absorbing radiation from the sun and converting it into electrical power, that is photovoltaic effect, by proposed method. The electrical power to batteries obtained from the solar PV modules, which might be associated either in series or parallel, and charge controllers. To transfer the ultimate power point in the solar panel, in addition, maximum power point tracker controller is used. The buck boost converter boosts up the DC power voltage generated from the solar PV panel and its output fed to a voltage source inverter. Voltage source inverter converts the AC power from a solar DC power and ultimately tracks the brushless DC motor, which controls the vehicle's application. But let's not go too technical just yet. Did you know that in the past, electric vehicles have struggled with limited range and long charging times? That's where photovoltaic solar based electric vehicle design comes in. A photovoltaic solar based electric vehicle design is a system that integrates solar panels onto the surface of the electric vehicle to design electricity from the sun's energy. This renewable energy can be used to power the electric vehicle or recharge its batteries. Here are some of the additional details about each component of the system. Now, let's talk about the solar panels themselves. The solar panels are made up of photovoltaic cell that converts sunlight into electrical energy. The panel are mounted on the roof, hood or the other surfaces of the electric vehicle to maximize the exposure to the sun. The solar panels are designed to withstand harsh weather conditions and can last for up to 25 years. One example of a PV solar based electric vehicle design is a Lightyear 1. Lightyear 1, an electrical vehicle equipped with solar panels on the roof or hood and other sides of the wheel. The Lightyear 1 is designed to have a range for up to 450 miles, and with 12 square meters of solar panels generated up to 12,000 miles worth of energy per year. That's significant improvement over traditional electric vehicles. So, how do all these components work together? Let's see. So basically, the buck boost converter is used to boost up the DC voltage generated from the solar PV panel to to the required level of the inverter. It regulates the output voltage to the inverter by adjusting the duty cycle of the switch. The electric motor is the power source of the vehicle, and it is powered by the electricity stored in the battery. The motor is much more efficient than traditional gasoline engine, making the electrical vehicle environmentally friendly and cost efficient in long term. The Nissan Leaf is an example of an electric vehicle that uses an electric motor to power the vehicle. The Leaf has a range of up to 150 miles on a single charge, and it's known for its smooth and quiet ride. Then the charge controller regulates the amount of electricity that flows from the solar panel to the battery to ensure that it is charged at optimal rate. The controller also protects the battery from overcharging and discharging. An example of charge controller is a Midnight Solar Classic, which is designed to power with solar panels and wind turbines to regulate the voltage and current of the energy generated. Whereas the battery stored in the energy generated from by the solar panels and generates the electric motor power to the electric motor of the vehicle. The battery is typically an lithium ion battery, which is lightweight and has a high energy density. The Tesla S model is an example of EV that uses an lithium ion battery pack to store the energy. The battery pack has a range of up to 373 miles on a single charge, making it one of the longest range electric vehicles available in the market. It is important to note that solar powered electric vehicles are not solely reliant on solar power only for their energy needs, but they can also be charged using a standard electric charge station or plugged into a household power outlet. However, the energy use of the energy of solar power can significantly reduce the amount of electricity required from other sources and can make the vehicle more environmentally friendly. Now let us come back to an AC inverter, which converts the DC electricity generated by the solar panels and stored into the battery in the battery into AC electricity that can be used to power the EV's motor. The inverter is controlled by a microcontroller that ensures a stable output voltage and frequency. One such example of an inverter is SMA, Sunny Island, which is designed to convert DC electricity from solar panels into AC electricity that can be used to power homes or electric vehicles also. But it's not just about generating energy from sun. These vehicles are also incredibly smart. For example, brushless DC motor. The brushless DC motor is the power source for the vehicle, and it is powered by the AC power generated by the voltage source inverter. The motor is controlled by an electronic motor controller which regulates the speed and torque of the motor according to the driver's command. Regenerative braking is a feature that allows the electric motor to act as a generator when brakes are applied. The kinetic energy generated by the brakes is converted into electrical energy and stored into the battery. This feature increases the vehicle's efficiency and range. An example of vehicle that uses regenerative braking is BMW i3, which can recover up to 75% of the kinetic energy generated when braking. This feature increases the vehicle's efficiency and range. Practically, when the vehicle is exposed to sunlight, the solar panels generate electricity and send it into the battery pack. The battery pack stores the electricity until it is needed to power the vehicle. When the drivers accelerate, the electric motor draws power from the battery pack to move the vehicle. And that's a wrap up. We hope you enjoyed the learning about photovoltaic solar based electric vehicle design. Overall, a PV solar based electric vehicle design is a sustainable and efficient way to power an electric vehicle, reducing the reliance on grid electricity and increasing the range of the vehicle. This effectiveness of the system depends on factors such as the amount of sunlight, the efficiency of the solar panels, and the capacity of the battery also. By harnessing this power of the sun and converting into electrical power, the vehicle becomes more environmentally friendly and reduces its reliance on grid electricity. From solar panels to battery packs, we have covered the basics of how this vehicle works. If you have any questions or comments, please leave it them down in the comment section, and don't forget to subscribe for more informative videos like this. And thanks for watching.